Very good morning, students. This is Dr. Megha Rai, Assistant Professor, Dr. Rafiq Zakaria College for Women, Aurangabad. In last two lectures, we have discussed about the measurement and calculations, the quantities related to the calculations, SI units, 7 different SI units, decimal fractions. We have discussed about the symbols and also about some important conversions. In second part, I discuss I revised. These things you know very well, but I am only going to revise all the things like atom, molecule, compound, mixture, separation techniques. You know very higher level of chemistry, but in interviews or in some of the exams, they are asking very basic questions. Define atom, define molecule, define compounds, define mixtures, what are the separation techniques, what separation technique you have used in laboratory, such type of questions I'm trying to cover in this basic concepts. Now the third part is laws of chemical combination, law of conservation of mass, law of conservation of mass. It is given by Lavoisier. Second is law of definite proportion given by Joseph Proust, law of multiple proportion given by Dalton, law of reciprocal proportion given by Richter, and law of combining volumes given by Gay-Lussac. In this, what we are actually going to discuss, the total mass of the product is always equal to the total mass reactant in chemical reaction. Means neither be created nor be destroyed. Fixed ratio by their weights. Different weight of an element that combines with fixed weight of others. Law of definite proportion. It is given by Joseph Proust. Actually, see very interesting example here. It is given. That is copper carbonate, natural copper carbonate having the percentage of copper about 51.35 and percentage of oxygen about 38.91% of oxygen. Total percentage of carbon is 1.74. It is 9.74. So, the second thing, that is synthetic copper carbonate. In that the percentage of copper is 51.35, whereas percentage of oxygen is 38.91 and the percentage of carbon is 9.74. What here I want to prove is, we are preparing the copper carbonate synthetically, even though the proportion of copper and oxygen and carbon is same as it is naturally present. A given compound always contains exactly the same proportion of elements by weight. Second thing, law of multiple proportion given by John Dalton in 1803. See the nice example, that is hydrogen plus oxygen. Everybody knows it is converted to water. 2 grams of hydrogen, because atomic mass, or we are taking 2 grams of oxygen plus oxygen is 16 grams. Total H2O is 18 gram. Water is 18 gram. It is found that 2 masses of oxygen, that is 16 grams, and 32 grams, that is 16 into 2, that is 1:2. So the ratio of the small whole number, 2 grams of hydrogen reacts with 32 grams of oxygen to form hydrogen peroxide, that is H2O2. O2. In case of water, H2O, 2 grams of hydrogen reacts with 1 gram, that is 1 part, that is 16 grams of oxygen. So, multiple proportion, it is a multiple proportion, that is 1:2. Gay-Lussac law. It is also called law of gaseous volume. When gases combine, they produce in a chemical reaction. They do so in a simple ratio by volume, provided all gases are at same temperature and pressure. What Gay-Lussac's law says? First of all, it is a law of gaseous volume. It is a law of gaseous volume. When gases combine, produce or they react with each other, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure. So 100 hydrogen plus oxygen, 100 ml, and that is 2 volume of hydrogen plus 1 volume of oxygen. So 100 ml plus 50 ml. Finally the water is 100 ml, that is 2 volume, 2 into 1, that is 2:1:2. So in case of law of definite proportion, you have to remember 2 things, that is Joseph Prost. Don't forget the name, that is Joseph Prost. And 2 nice examples are given, that is copper carbonate, which is naturally given, and copper carbonate, which is synthetically provided. Both have the same percentage of copper plus oxygen plus carbon. Next one is law of multiple proportion, which is given by John Dalton in 1803. And the third one is Gay-Lussac's law, law of gaseous volume. In that, what you have to remember, simple ratio by volume, provided all gases have the same temperature and pressure. Next one is Avogadro's law. Avogadro's law is given by Avogadro, and it was in the year 1811. What he proposed? Avogadro proposed equal volumes of all gases. Avogadro proposed equal volumes of all gases at the same temperature and pressure contain equal number of molecules. Avogadro proposed equal volume of gases at the same temperature and pressure contain equal number of molecules. So, hydrogen, that is 2 volume, oxygen 1 volume, and finally there is a formation of water, that is 2n into n, and finally 2n, that is the example is hydrogen plus oxygen, it is converted to 2 volume of water. This is all about the general discussion of laws of chemical combination. Here I have again tried to revise the general part for the fast preparation of your competitive section. See the another part, that is average atomic mass. And before going to the average atomic mass, molecular mass, formula mass, we have to study some basic concepts of, that is, what do you understand by the weight, atomic weight, molecular weight? Atomic weight of an element is equal to weight of an average atom, weight of an average atom divided by 1/12 into mass of carbon. Remember this thing because it is needed again for our calculations. Molecular weight is equal to weight of one molecule of the substance divided by 1/12 multiplied by weight of carbon 12. This is all about the third part of basic concept of chemistry. Thank you.